Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC B1846, pertains to a malfunction in the power seat front up-down switch circuit of the Honda Odyssey models from 2011 to 2017. This DTC indicates that there may be an issue with the electric power seat's control mechanism, specifically its up-down functionality. The primary affected components include the power seat control unit and the front up-down switch itself, which are critical for adjusting the seat's height and position to ensure driver comfort and visibility. The power seat control unit is usually located under the driver's seat, while the switch is positioned on the side of the seat for easy access. When this error code triggers during diagnostics, it can affect the overall operability of the power seat features, necessitating careful troubleshooting to pinpoint the underlying issue. Proper handling and understanding of DTCs are crucial for effective repair, as they guide technicians to the root cause of the malfunction. The error code B1846 directly indicates a malfunction in the power seat's up-down switch circuit. The power seat control unit plays a vital role in regulating the seat's electrical movements. It is responsible for receiving signals from the front up-down switch and executing the desired height adjustments accordingly. Typically, the control unit is nestled underneath the driver's seat, where it connects to various electrical components. The front up-down switch, which is mounted on the side of the seat, allows the driver to easily operate the height adjustment feature. If this connection fails or is disrupted, it can lead to the DTC being triggered. Proper identification of this malfunction is essential, as it directly impacts driving comfort and safety. There are several potential causes for the DTC B1846, highlighting areas that technicians need to inspect thoroughly. A common issue is a short to ground, near the electrical wiring could be making unintended contact with the ground, disrupting circuit functionality. Additionally, poor connections, either due to corrosion or loose wiring, can impede electrical flow, potentially leading to the error code being triggered. Faulty power seat control units also remain a viable cause. If the control unit itself is malfunctioning, it may fail to properly translate the switch signals. Understanding these causes is critical to efficiently troubleshooting the circuit malfunctions to restore the power seat's functionality. The symptoms associated with the DTC B1846 are primarily centered around the power seat's functionality. The most apparent symptom is a completely inoperable up and down adjustment feature, which inhibits the driver's ability to set their preferred seating position. Additionally, there may be intermittent electrical issues, meaning that the power seat occasionally works but loses functionality unpredictably. The vehicle's warning indicators may also activate when this code is present, signaling to the driver that there is a malfunction that requires attention. Identifying these symptoms is key for technicians to understand the severity and scope of the issue at hand. The first step in troubleshooting the DTC B1846 involves using the Honda Diagnostics System, HDS, to clear any stored diagnostic trouble codes. Clearing the codes allows technicians to reset the vehicle's computer, which can help determine if the issue persists or was merely a transient failure. Following this, the ignition switch should be turned to the lock position to reset the system entirely. It's crucial to switch back to the on position afterward, as this prepares the vehicle for further diagnostics. This initial clearing step sets the foundation for accurate troubleshooting by enabling more focused diagnostic efforts. After the DTCs are cleared, the next step requires operating the front up-down switch in both directions. This action should be performed for at least 1 second each way to ensure that the control unit accurately registers the signals. It's important that technicians observe the response of the switch and note any irregularities during operation. Proper functioning indicates that the switch is likely working as intended. If the DTC B1846 reappears following this operation, it suggests that the underlying issue is still present and further investigation is necessary. Following the operation of the front up-down switch, a crucial next step is to check for any present DTCs using the HDS once again. This reevaluation serves to confirm whether DTC B1846 has been triggered again after the initial troubleshooting efforts. If the code reappears, this indicates an ongoing malfunction within the power seat circuit. Conversely, if the code does not appear, the issue could be categorized as intermittent, suggesting the system may be functioning properly at that time. Technicians should look for potential loose or poor connections in this scenario, as they may have temporarily disrupted the power seat's functionality. In this step, the ignition switch should be turned to the lock position again to ensure that there is no active electrical supply while accessing the components. Next, it is necessary to disconnect two specific connectors, the power seat control unit connector B and the power seat adjustment switch connector, usually labeled as 12P. Removing these connectors is essential for safely testing the circuit without risk of electrical shock or damage to the components. After disconnection, the technician can start preparing for the continuity checks to investigate the connection pathways further, focusing on whether signals are appropriately transmitted to the power seat unit. This step involves checking for continuity between body ground and specific terminals of the power seat control unit connector B. Terminals 16, 17, and 20 need to be tested individually to verify if there's proper continuity. Each terminal corresponds to important signals that determine the operational state of the power seat's functions. A positive continuity test indicates that these wires are correctly linked to the ground and there are no breaks. Conversely, a lack of continuity will suggest that there could be a short to ground in the wiring, which necessitates immediate repair or replacement to address the circuit malfunction. In this crucial step, the technician must check for continuity between specific pairs of terminals in the B connector of the power seat control unit. The pairs that require testing include terminals 16 and 17, as well as 16 and 20, and finally 17 and 20. Each of these pairs is vital for the proper functioning of the power seat's adjustment features. Successful continuity between these terminals indicates that the internal wiring is intact, allowing for the smooth operation of the up-down adjustment function. If any pair shows a lack of continuity, further investigation into the circuit should be performed to find potential damages or disconnections that could lead to the triggering of DTC B1846. After completing the necessary repairs or adjustments indicated by the previous troubleshooting steps, reconnect all connectors that were previously disconnected, ensuring they are firmly seated to avoid future issues. After reconnection, it's important to clear any DTCs using the HDS. This resetting allows the power seat system to recalibrate and aids in determining if the issue has been successfully resolved. Once cleared, test the operation of the power seat in the up and down motions to verify functionality. If the seat responds correctly, it indicates that the repairs were effective and the system is operating within the specifications. To prevent future occurrences of DTC B1846, implementing a proactive maintenance schedule is essential. Regular inspections of the power seat wiring should be conducted, focusing on any signs of wear, fraying, or potential shorts that may lead to electrical malfunctions. Ensuring that all connections remain tight and free from corrosion can significantly improve the reliability of the seat's functionalities. Additionally, cleaning the switch contacts periodically will help maintain a clear electrical path and reduce the likelihood of failures caused by corrosion or dirt accumulation. Taking these preventive steps can extend the lifespan of the power seat system, ultimately contributing to a more comfortable driving experience. In summary, effectively troubleshooting the DTC B1846 for the Honda Odyssey from 2011 to 2017 requires a systematic approach that begins with clearing the codes using the Honda Diagnostics system. Identifying any wiring issues, performing continuity tests, and ensuring sound connections are essential steps in diagnosing the problem. Once repairs are made, thorough testing ensures that the adjustments are functioning correctly again. Implementing regular maintenance checks can help prevent similar issues in the future, preserving the power seat's integrity and functionality for safer driving experiences. By adhering to this guide, technicians can confidently navigate the intricacies of the power seat circuit and restore optimal vehicle operation. Please like and subscribe to the channel. See you next time.